Hello everyone. So today we are going to solve the GFG problem of the day, which is marked medium, but I think it's easy. Okay, you have given two integer L and R, and we have to find the bitwise end from L to R. Okay, like suppose L is 8 and this one is 13, then we are going to find the bitwise end of 8 to 30. Okay, and similarly from 2 to 3. So one way is like we can directly take a loop, and from 8 to 13 we are going to find the end, we are going to read. Okay, this will work, but constraint is high, because if we see constraint, then this constraint is high. Okay, so now how we can do? Okay, so if we think like, okay, what are the things that came in our mind when we talk about the end? End means, okay, like if any bit, if we are on any ith position, if any bit in that ith position is 0, then that become that equivalent to 0. Okay, so if we take like suppose 8 is there, 8 to 13 is there. Okay, so actually I want to show you, because I need to text write more. Okay, okay, now suppose this one is L is 8 and another is 13. Okay, so if we say like I have written from 8 to 13 and we are going to find the job, then answer is, okay, 8. Okay, similarly if we talk about 2 3, this one is going to 1, and this is because if any 0 is there, that is going to contribute 0 0. Similarly 12 and 15 is there. Okay, 10 15, these are there. Okay, what the catch is, if we are on left and we are on right. Okay, what is that? L and R is there, so L is the smaller number, that means, or either it can be L equal to R. So from L to R we are going. Okay, so it might be, if we write like L is 1000 and R is this one, it might be that this L and R have some bit from the, what we said, this side. Okay, from this side might be equal or might not be, right? It cannot be also. Okay, so but one things we know, that if any bit, like if this one matched with this right, then all the bit between L and R must match that. Like if this one is 1 and right is also 1, then all the bit inside there must be 1, if we are seeing from right. Okay, this is, if we take this is left, then okay, like if we say this one is 0 and this one is 1. Okay, so now we break here. Okay, now we can't say like if this was is 0 and this is 0, that means no. Once we break, that means now we can't see. So we are going from the right side. If any bit changed, okay, then the story is over, and until the bit is same, that means all the things are same. Like if we say this one is 1, this one is 1, so all should be 1. Like if you take about this is 1, this is 1, that means between also there is 1. If this is 1, this is 1. Okay, now this is 0 and 1, this changed, so we can't take the next things by comparing, like whether the left bit is same, left and right bits are same or not. So moral of the thing is, we are going to find that how what are the, up to which the left bit and right bit are same, that is not going to change, and otherwise every bit could change, and if that could change, there might be 0 and 1. Okay, so now take an example like this 21 23. Okay, so in 21, okay, this one is in 23. So if we see like 101, this one, this section get matched, so all the, in every number this section would be same. Now this is 0, this is 1, and whatever the things are, so we are going to do, okay, 0. Now the better way to utilize it is like, what this means, this left is 101 and right is this 101, or either this one is 1 1, this one is 1 1, or this one 1. So this simply means these the value of 101 and 100 is correct. So what we can do, how the question is like, suppose we, okay, we, how we get this, how we compare this, like from right side up to which we are same. Okay, so thing is simple, like, okay, we are going to do the right shift. Okay, and what the right shift do generally, if there are right shift, just make this one type, so this one become vanish for the first time, second time this 0 become vanish, so this 101 became. Similarly in the first time this vanish, second time this vanish. We are going to do the right shift of the both section, and whenever they match, that means that is the section which is common in both. Okay, and other part, each note. Okay, so other party is going to contribute 0 0. Okay, now how we are going to do? So we will going to do right shift of 12 also and 15 also. Okay, like if I say you, like suppose take in this example 8 and 13. So here this one is okay 8 and this one is 13. So first when we do the shift, right shift, but this become 1 0 0, which is 4, and this become 110. Okay, now if this value, if this right is greater, okay, okay, if this would be same 100, then that is the another story. Okay, so if this is big, that means still some bit is there which is changing. Okay, so we move one side, so this become 10 and this become 1 1, right? Okay, now still this is bigger, that means there is something still going on, some bit still changing, so we are going to move one more step. So now it become, okay, this will give 1 1. Now left is also 1 and right is also 1, that means both become same. Now we can't move ahead. Okay, okay, so now, so what this means, this means that this one bit is same and another is different. Okay, now our task is we will put this one here and the rest bit as 0 0 0. Okay, similarly if we think of like this one 1 1 0 0 is there, so first right shift the 1 1 0, then 1 1. Similarly in two shift we are going to get this number same, that means left and right becomes same, and left and right becomes same, that means now all the things are, that means this 1 1 or whatever the things are, that would be same. Okay, so now our task is like to put the rest bit as 0 0, because these are the changing bit, that's why the value of left and right are different. Okay, now take one example, this 101, this 101 is there. When we do one shift, then this become, this one get removed from there. Okay, this still is greater than 1, that means some bit is changing. Okay, now we move this become 101 101, so both are same, that means bit are not changing. Okay, that means value is not there, that means bit is not changing, we stop there, and whatever the positions that are, we are going to replace with 0. Now the things is how we will replace that with 0. Okay, right? So while doing the right shift, that means one right shift remove this one, second right shift. Okay, so number of right shift we did, uh, okay, so now this one is there, two right shifted, so we are going to put 2 0, so we will do 2 times left shift. Okay, so now let become more clear from the code. Okay, so okay, now while L is less than R, L is less than R means that some bit are differing. Okay, so what we are going to do is we are going to increase our shift, that means we have made the one shift. Okay, int shift equal to, we are going to make the first shift. Okay, and we make L equal to L right shift of right shift, then we make R equal to R of right shift, right? Okay, now this is going to make the number of shifts. Okay, now what would be our answer? The number of shift, whatever the shift is there, we are going to return like whatever either L or R is there, because both are same. Okay, whenever they are changing, we are going to change. So now these both are same. If both are same, then what we are going to do, L, okay, or R, we can write anything. Suppose now we do left shift of shift, because this shift is the number of count which is going to removing from the left side. So this again we are going to add, but this time we are adding 0. Okay, now if we compile, if we take about the complexity, so whatever the L and R is there, we are going to do the right shift. Okay, that means L by 2, L by 2. So this is going to be log n time complexity will log n. We are not going to use any space. Okay, so space is 0. Okay, thanks for watching.